There we go. So the series we learned yesterday was the function 1 over 1 minus x is equal to, and do you remember the formula of this power series?
1 plus x squared.
Isn't it lovely?
Yes.
And I heard something online. Yes. See, when you're not there, Taya takes over. All right. Now, you have already done, I've already talked to you about differentiation and integration. But I'm just going to throw this out there because I didn't give you this officially before. If you have f of x, a polynomial centered at x equals a, and you know that it is continuous over a particular interval with or without the endpoints known. So this could be just an open interval or a closed interval, either or is what I meant to say. Now, you know how to take the derivative, but what I haven't mentioned is the issue of interval of convergence. What you need to know is when you take the derivative, the center of the power series will not change. The radius of convergence will not change. However, the endpoints might change. So what does that say? That says if you know the interval of convergence, you take the derivative or you take the integral, it will keep that same open interval, but the endpoints have to be checked. And that's all. It's just those endpoints have to be checked. And I've talked about this issue with integration already. And now what I'm going to have you do is take the derivative of this function, first just looking at what is d dx of 1 over 1 minus x. So everybody take that derivative. Oh, thank you. It was pointed out that I forgot an x. Of course, you know who pointed it out because that is the person that I've been depending on. Does it feel good to be here on campus? Yeah. I'm just so glad that we at least got that first round of vaccines first. I feel so much safer with that. Wait, Chris, you are here. I did the wrong attendance. I've got to go back on that again. Okay, I apologize. I temporarily need to check attendance. Actually, I'll do it this way. I know those three are here. Okay, is one of you Luca? Neither of you are Luca. Luca is the one who's absent.
I'm here, but
online.
On my computer.
All right. I just have to make sure to correctly have attendance in as far as who's present on campus. It's really the extra paperwork they have us do is, oh my goodness. All right. So you've had time to take this derivative. Here we go. You know that this is to the negative 1 power. So we end up getting negative blah to the negative 2. And then the chain rule says plug in the function and multiply by its derivative, which is negative 1. So I get the function 1 over parentheses 1 minus x quantity squared when I take the derivative of this one particular function that I know a power series for. So let's now take the derivative of this power series. So do the polynomial's derivative. And derivative of 1, we get 0. I just realized I can't see your chat right now because I moved things around. There we go. One less nerd in the chat. Got to make up the difference.
Can't wait till she comes to campus. We'll get a pancake.
Yeah. You know, it's interesting because it seems like, well, it is, there are more freshmen than sophomores, than juniors, than seniors. And, you know, I can't blame them. It's, especially seniors at this time, this is usually the time where it's hard for seniors to continue to actually physically get up and go on campus. I actually feel like I'm probably going to keep the seniors more by having them online. I remember hearing things from seniors who said, you know, I was on my way to school, but then I saw the ocean and I decided, nah, let's just go to the beach. Totally honest about it the next day. I'm just like, okay, thanks for telling me. All right, derivative, we get 1 plus 2x plus 3x squared, dot, 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 and then n times x to the n minus 1. So know that, and if you want to, you can. If you go into Desmos or any graphing device and you graph that function and then a few terms of this polynomial, you'll see that it does look pretty good between -1 and 1. However, we have to check the endpoints because this math problem is being very particular. So the interval of convergence of the original is -1 to 1. That means that this series is convergent for either open or closed, or sorry, I said that backward, closed or open, -1, 1, and then either closed or open. We've got to figure out which it is of both of those, and we will use the formula. And we are checking when x is equal to -1 and when x is equal to +1. So if I replace that x with a -1, I have n times -1 to the n minus 1. And I don't remember what n it started with. I'm just going to put a 1 down. And over here, if I plug +1 in here, then all I get is just plain n. Now, let me actually save a little bit of time by talking about this one first. Look at that one. Do you see converge or diverge with the one that I just highlighted? And wait. Oh, the answer to the question that I'm seeing over there, when you do the chain rule, you get an extra times -1, and that made it plus. And so it actually turned into the positive of it. And I've got a Jackie hand, yes.
Do you need to find the derivative of like the actual 1 over 1 minus x? Because when I just kind of did, I just found the derivative from 1 over 1 minus x. Is it going to come and be important to have that new expression?
The thing that's important is knowing what function it's representing. Okay. So this way you know that this is trying to mimic that function in particular. And then looking at this, does everyone see that that's a diverge and why? And I just saw the all caps message there, spoken from a sophomore. I still remember one sophomore telling a senior, that they should have enough time to get their homework done. And that senior was quite offended. When that sophomore was a senior, I asked, so how would you feel now if a sophomore said that to you? I didn't get a response. So everyone sees diverge. And hopefully you can see that's by the divergence test, the nth term test for divergence. And just to make sure you see it, the formula itself is certainly not 0. Now, if you think about what this is creating, and then you think about if I turn that into an alternating series, am I going to get converge out of that? 1 plus 2 plus 3 plus 4 plus 5. Now make it alternating. 1 minus 2 plus 3 minus 4 plus 5. No. And the divergence test, the nth term test for divergence will take that also. With that one, you would just say the limit as n approaches infinity of, and I'm changing the order of multiplication, that's fine, that this is a limit that just does not exist. If it is a does not exist, then it diverges by the nth term test for divergence. And I'm just going to say here too, the ditto. Does that mean ditto to you guys still? Only this means ditto? Or is it this that means ditto?
Oh, you're doing like a quotation mark?
Yeah.
Oh, yeah. That's...
Okay. I don't know. Things change as, and I have to make sure that you guys know what I'm writing now. So those two little, I'm noticing that a lot of people are using these.
Oh, in like the chat, then yeah, people do use the little caret to like point above. Like,
Oh, that's what it's referring to. Thank you. I was wondering why they were using them, but I just noticed it was a thing.
oh, you know, basically it's the same thing, but it makes more sense in the chat to just put that little arrow to the...
That makes sense. So that's ditto, any way you want to write ditto. So what does that mean? That means the interval of convergence is the open interval from -1 to 1 still. And now let me share with you that we just, it's okay. This is better than using Google Chrome. So we just did example 5 in the book. It asked you to express this function as a power series by differentiating the original equation, and then it only asked for the radius of convergence, but I threw in the whole interval of convergence. And the radius of convergence, you guys all see that that's 1. Okay. Now, the next thing I'm going to have you do is I'm going to have you integrate 1 over 1 minus x. I'm going to erase the work that I have here for the derivative. Or, no, wait, I can do this. I've got my lasso back. Because also when I use Google Chrome, I can't sign into everything that works better than what's provided. So I'm happy to have my lasso back now. All right, we are going to look at what is the integral of 1 over 1 minus x. And while you do it, I'm going to write it down. I'll give you a moment to be ahead of me and think about it. And let me see. Oh, nobody has enough time to get their homework done. But you do it anyway because you have to. You guys do know that I want you to get sleep over getting my homework done, and you can always tell me. I try to tell students that, but I don't know if they always hear it. If you have put in a ton of time in homework, you can always let me know and I'll give you extensions. And I've been a little bit lenient on a quantity of late work as long as it's reasonable or you had a good reason. All right, you're doing a U substitution. And then this becomes the integral of 1 over u times negative du. And so when we integrate, we get negative natural log of the absolute value of u, and we put the u back in. Now, do I need the absolute values around the 1 minus x? Take a moment. And yes, the plus c. But I want you to take a moment to just, without looking at the plus c in the mix of it, do you see that the absolute, okay, apparently I have to put plus c. They're completely focused on that, and now you can let go. And now, absolute values, do I need them? And notice what I highlighted. When you integrate in a power series, so let me make sure I'm clear to you, actually. I am looking at this power series and what I'm going to need to change this power series to mimic this integral. So you know what? I just realized that I didn't really explain the whole thing. Normally you need absolute values, but since we're only going to be representing this function with this power series, with this interval of convergence, since that interval of convergence is the focus, that's the only domain I can work with. And I might have to include -1 or 1, but I want to point out to you that as long as x is between -1 and 1, I don't need an absolute value. And since that's the domain that I'm focused on, I can stop writing that absolute value. Now, with that partially done, I want to turn over to what the next example is. The next example wants you to find a power series representation for the natural log of 1 minus x and its radius of convergence. I'm going to go with the whole interval of convergence altogether. So what we just found was, if we flat out integrate 1 over 1 minus x, we get the function negative natural log, and I'm going to stop using the absolute values right here. I get this function when I integrate. Yes, plus c, but just hold on for a moment. If I want this to be this function, what do I need to additionally do? Multiply by -1. So what I'm going to do is I'm going to write down specifically I need to integrate, and then I need to multiply by -1. And when I do that, the function will turn into the positive natural log of 1 minus x. So now I need to bring the power series into the mix. 1 over 1 minus x is our friendly x to the n power series. Yeah, thank you, Jackie. All right, When I integrate, I put that plus c in front. So I have c plus, and then I integrate 1. I integrate x. I integrate x squared, and so on. So that is giving me this. And I want you to see that if I'm solving that indefinite integral, I am getting a plus c, but I don't need to have it written with both the function side and the power series, because my focus is actually the power series. And then I'm going to multiply that by -1 to get and I'm going to write just flat out -1 times x to the n plus 1 over n plus 1 for the formula. Now, let's look at what we actually have here, because we're not quite done. We're supposed to find a power series representation for this specific function. That's a very specific function. That doesn't have a plus c involved. So what we're going to do is we're going to take our last equation, which is, and I'm rewriting it just for the sake of re-emphasis. Natural log of 1 minus x is equal to some constant, and then all this stuff added on. Now, look at the polynomial. What is the center of this polynomial? And let's see, do you have it online, the center of the polynomial? If you see just x, not parentheses, x plus or minus a number, then the center is just 0. It's fine. I make more mistakes than anyone else, so don't even worry about making mistakes. Now, because I know the center of the polynomial, that is one particular x that I can plug into this equation and get an actual numerical answer here. So I'm going to plug in x equals 0 to determine what c is. So on the left side, I plug in 0. On the right side, I plug in 0. And however frustrating this might be, this does have to be done. What is the natural log of 1 equal to? So you end up with, oh my goodness, c is 0. So if you hadn't written it, you would have been right. I find that incredibly aggravating. But know that that is something that should be checked. That means that we can represent this particular function with this specific power series. And it is equal to. The only thing left is, let's look at the interval of convergence. And I want to make sure you're clear that because I integrated, I didn't change the open interval of convergence. The original polynomial had an interval of convergence of -1 to 1. When I integrated, I ran into the question of, is it including endpoints, yes or no? Multiplying by -1 is not going to affect anything with interval of convergence. And the solving for C was just its own thing. So basically, I can take this formula, or if I prefer, I could take this formula. If you look at the two of them, do you see that they give you the same, they're going to give you the same answer for converge diverge. And whichever one you want to use, the endpoints have to be checked. And I'm going to go ahead and use the more confusing one, just so I can point out to you how to work with it. So I have -1 times x to the n plus 1 over n plus 1. And I'm plugging a -1 in where that x is. And I want you to see that if I have this -1 over here to the understood 1 power, and I'm multiplying by -1 to the n plus 1, what's another way to write this? And even more crazy, how else could I write it and it would be the same thing? Making sure you're awake. Are you awake online? All right. And I see it right there. It could be to just the n. And it's the same either way. But with that aside, do you see that this is an alternating series? Is it going to be a converging alternating series? The absolute value of its formula is something that will decrease to 0.
You have to show, can you just say converge by AST?
Yeah.
You can just say converge by AST.
You can just say converges by AST. I just want to make sure to clarify to you what's behind it. If you are doing a free response test and you're finding interval of convergence, the most they ask of you is to just check the endpoints, show that you check them, say whether you're getting convergent or divergent, and what test leads to it. But you don't have to show the working of the test. All right, if I plug in x equals 1, then I have -1 by itself. When I plug in a 1 instead of a -1, I'm just getting 1. I'll go ahead and write it. So realize that 1 to the n plus 1 is 1, and it gets ignored. Now be careful here because it's really, really tempting to see this and go, alternating series, but it doesn't have an exponent on it. And so it's not an alternating series. In fact, if I bring that negative sign outside of sigma, I can see more clearly that I have a harmonic series, and it is diverge. And you are allowed to say diverge by harmonic series. So you just got to see that when you integrated this, you ended up gaining an endpoint. Not both of them, but you gained an endpoint in the interval of convergence. So the final answer is inclusive of -1, not inclusive of +1, and that is your interval of convergence. Yes, and the radius is 1. The radius will not change by integration, but it can gain endpoints. All right, now. Yes. Yeah. If you rewrite it as that, keep the -1 still, but x to the n over n, it's still the same pattern. That just means that there's an understanding that the starting n is different. But whatever starting n is, you should get -x out of it. All right. Now, one last example that needs to be done, and then we can look at some homework. Inverse tangent, does that look familiar? What is its relationship with 1 over 1 plus x squared? So what I want you to think about is, if you're starting with this known series, you want to think about, to get to inverse tangent, you need to integrate 1 over 1 plus x squared. Do some of you see the path you need to take? Before you go through integration, you need to make that denominator become 1 plus x squared. And to do that, you will plug into x. I don't know why I can't write. There we go. What are we plugging into x to change this denominator? And online, do you guys see it? Yay. I need to hear some, what's the word for? I need some representation, but I'm trying to do the slang version and I don't remember. Anyway, juniors, represent. Seniors, represent. Come on. Is that the right word?
Yeah.
Is that the slang? Okay. Come on, let's represent. There we go. Woo! And I'm going to write down the function that I get when I do that. And then I'm going to write down that my next step is to integrate. And when I integrate this function, I know that that is giving me inverse tangent. Yes, there is a plus unknown constant, but my actual focus is the power series, not this function. The reason that I'm actually going through these processes is to make sure that I'm getting the function I think I'm getting by doing these two things. We know that we get the plus c but it's the polynomial who needs to take that plus c, especially when we're going to need to write an equation. Arctangent equals a power series that starts off with c plus, and we'll be able to find out what that c is. So I'll let that be thrown out there so you have your plus c. And now, let's do the process. 1 plus x squared. And then when I plug in negative x squared, negative squared goes positive, and then squared squared. And it's important that you separate the negative that is plugged in and the x squared that is plugged in. And x squared to the n, multiply the exponents. Now when you integrate, you've got that unknown constant plus, and then integrate x, integrate, integrate. And so I go plus 1 divided by, and we've got it. We do need to figure out what that c is. What can we do to find it? Answer to Landon's question, if you want, you can just write sigma. And it is often easier. I'm presenting, I want to keep presenting the first few terms and the general term to cover all the bases of what you would need to possibly work with. So what is the center of that polynomial? 0. So you are going to find c by plugging in x equals 0, the center of the polynomial. And that gives me arctangent of 0 equals c plus 0 forever. What is the arctangent of 0? Frustratingly, yes. Yet again, we get that unknown constant is 0, but the work had to be done. As a final answer, and I'm going to save us a little bit of time. I feel like, okay. I'm going to save us a little bit of time by saying that this is the answer to arctan x. We do need the interval of convergence. Now, do you remember that when we plug in negative x squared, let me change to this color. When I'm dealing with 1 over 1 minus x, interval of convergence is negative 1 to 1. When I plug in negative x squared, that becomes my r in a geometric series. And we've done it already, so do you remember what that brought about? No change in the interval of convergence. Then when we integrated, we're still between negative 1 and 1, but we have opened up the possibility that we might converge at the endpoint, so those need to be checked. So I have my friendly negative 1 to the n, and then I am plugging in my x, and I'll plug that in a moment. Take a good look at this. Take a good look at that. Negative 1 to the power of 2n plus 1. What does that simplify to? Keep going. Well, keep thinking about that.
Only that negative 1 squared and then times negative 1 right?
So ultimately, what does that negative 1 to the 2n plus 1 actually simplify to? Aw, listen to the cute sophomore working out her thoughts out loud. And it's flat out negative 1. Because when you look at the 2n plus 1, 2n forces an even number, plus 1 makes it be a forced odd number. So if it always has an odd exponent, then it's just always there. But I'm not losing the negative 1 to the n power. In fact, I'm really just gaining one more. And so that numerator, the entire numerator, can be simplified to negative 1 to the n plus 1. And I want to make sure you're clear on that. All of this simplifies to that. Now, do you see that you have an alternating series? Is this a converging alternating series? In fact, it's an alternating harmonic series, which we know is conditionally convergent. Now let's look at the other one. It just didn't get that special extra negative sign. But do you see that it is still also an alternating series? Still an alternating series, and it converges. So that means my final answer is what I boxed here, and then the interval of convergence is including endpoints. Now, do make sure if on an AP test they ask for the radius of convergence, you don't need to go through the whole endpoint checking. All you have to do is enough work to determine that the radius of convergence is 1. And in fact, this wouldn't require any work to determine that, because that radius of convergence is not able to change with any of the steps that we did. Now, here is a bottom line of what you need to be aware of. If you are expected to create a series where you have 1 over parentheses squared, and in that parentheses, maybe you have a 3 plus x, maybe you have a 5 minus x, maybe you have a 2x plus 1. But you've got some kind of version with that, is what I'm trying to say. Let me just kind of throw out there 2 plus x could be it. But what you have there is linear. If you see that you need a power series for that form, you're going to get there by starting with 1 over 1 minus x, do whatever needs to be done to make the denominator 2 plus x. change denominator. Then you know that you are going to get a parentheses squared in the denominator if you differentiate the function with that same denominator. And you're expected to realize this. If you are given 1 over parentheses cubed, and you have some linear thing in there, let's say it's 1 minus 2x, you're going to do step 1 and step 2, then you're going to do step 3, and then guess what you're going to do? You're going to differentiate again. And no, I will not. That's my answer to your question before you ask it. If that was a 4, you would have to differentiate 3 times. You get the pattern. So you are just expected to be aware of how to get to that through 1 over 1 minus x. Another thing you want to be on the lookout for is the natural log of something linear. That linear could be, I don't know, 5 minus 3x, whatever it may be. We have 10 minutes left. Know that you're going to get there by starting with the 1 over 1 minus x. Change the denominator. Denominator to being this. And then, what are you going to do? What are you going to do? Integrate. If you see inverse tangent, of some function in there, they're usually not too cruel about it. But let me tell you that the basic idea that you want to remember is start with 1 over 1 minus x. You need to change it so that you have a denominator that will be able to integrate and give you arctan x. And I would say that from there, after integration, you could substitute in any extras. But your goal is start with the 1 over 1 minus x, change it by plugging in the negative x squared, integrate, and then you might have to do more if there's extra. But just be aware of that trio of functions, and I've seen it show up on the AP test, so it is important. Now, I decided, I don't know if you saw what I posted at the end of lunch, but I added on to the calendar. I'm pushing more stuff out or back. I'm going to do just one quiz on the converge-diverge situation of choosing tests for converge-diverge, and then one test. Right now, that quiz is pushed to Friday. I'm going to keep working with you every day and see where you're at, because I know that this takes time. At some point, I'm going to have to cut it off. I'll tell you this. I'm hoping for Friday, but I'm willing to go to Monday, but that's followed by a Tuesday test. So I don't know if that's necessarily the best thing. But in the meantime, I am giving you College Board problems every day as a supplement. Today's homework, you have a supplement as well. And if you want to see the answers, you can go onto the MyAP site and then put in what you think are the correct answers to each of these 9 problems, and it will tell you if you're correct or not after you push submit. But I did put this as a PDF file, just in case you can't get on College Board.
Every time you design something on here, it's somehow shut.
Yeah, they're really good at shutting down. So what we have left is questions. I need to definitely go over these. And let me also ask, do you need to get help with some of the textbook problems as well? Yeah, number 9 specifically. Are there any other requests to go over textbook problems? Because I may have to just do a video later because we have now 6 minutes. Anyone online have any textbook problems they would like me to make a video going over? Okay, one thing that I want to make sure to talk about, because I remember that it was something that was important to look at. Which problem was it? Ah, yes, this one. I need to talk to you about this one. My recommendation is, if you ever see that you're expected to look at the comparison of the actual quantity between the integral and the sigma. You know that the integral test is involved here, but you have to additionally figure out, is your sigma supposed to show up as less than 5 or greater than 5? You're expected to see that because this is 5, your series will converge. The integral test is going to cause that to happen because f is positive, continuous, and decreasing. So what I highlighted in blue is the integral test, but what I've highlighted in yellow is an extra step you need to take. And this is what you want to do anytime you're faced with this. First of all, I need to draw an f of x that does this positive, decreasing, continuous thing. And I'm going to draw a line at x equals 1. And basically this area under the curve is 5, if I look at all of it forever out. Now, I need to look at sigma, and I need to see that it starts at n equals 1. When I plug in 1, I am getting this value, this y value right here. Does everyone see that I'm getting that y value for my sigma? Because it is finding f of 1. This is really important. This is what you have to look at first. Then, if you go 1 unit to the right, and you turn this into a rectangle that has a width of 1 unit multiplied by a height that is a sub 1, the area of this rectangle is the same number as you get with a sub 1. The next n that you would be plugging in is 2. So I'm trying to show that this is a sub 2. Then, while staying in the shaded region, go 1 unit to the right over to 3. And you have a rectangle with dimensions a sub 2 and 1, multiply, you get that area is the same thing as a sub 2. So if you start by figuring out whether, if this had started at n equals 2 instead, let me actually show you if the sigma had started at n equals 2, this one is sigma starting at n equals 1. Same formula. But if it had been starting at 2, and your integral was from 1 to infinity, then the first term that you have is a sub 2. You need to look at where your shaded region is for the integral. And then if this is your first term, you need to go back 1 unit to be able to compare the area that sigma creates in relation to the area that the integral creates. And with that, you can see that this is a sub 2, a sub 3, and I would have gotten the other answer if the sigma had started at 2. But I'm just telling you the best thing to do is to learn how to kind of draw this picture and see the relationship, because I can't guarantee you what the AP test is going to throw your way. But for this, which is what it was given, I have to be greater than 5 for my series.